Hello my dear students of BSc first semester, welcome to my class. So in the previous lectures we have done damped, oscillator, mechanical as well as electrical, similarly undamped and pendulums, clear, torsional pendulum, compound pendulum. Now we are going to start our second unit, and in the second unit the first topic is forced oscillator, that is the force oscillator, or in this also we will do force mechanical oscillator as well as force electrical oscillator, force electrical and force mechanical oscillator. So first we will do forced mechanical oscillator. So how we can define this oscillator? In the previous lectures we have, in the previous articles in the damped oscillators we have no external force. So from the name clear that here is some external force. So in this we apply some external force to an oscillator so that its oscillations doesn't die, कि उनकी oscillations जो है वो die ना हो, इसीलिए हम उसको क्या provide करेंगे? External force. क्या provide करेंगे? External force. We apply external force. So that's why its name is force oscillator. Its name is forced oscillator. So in the start, this the oscillator is oscillating with its own frequency. But when we apply a force, in the start it is going with its own frequency, oscillating with its own frequency. But at some time, the applied force dominating on it and its natural frequency dies, and it is fully under the effect of that force. At that time it is called a force oscillator or steady state behavior or steady state behavior. So first, how we can define this force mechanical oscillator? So an oscillator to which continuous excitation is provided. Continuous excitation is provided by some external agency. So continuous, we apply external force to it, and it consists of two parts. One is the driving force or driving agency, you can say driving agency, that is, you can say force, external force, driving agency. And this is F is equal to F naught e raised to power exponentially iota omega t, where omega is a frequency. This is external force which we give to the oscillator for continuous excitation, for continuous oscillations. And the second is a driven system, and driven system is the that is the oscillator. It is just like when we are going to drive a car. Car is a driven system, and the driver or individual which is driving the car is a driving agency. So it is force F is equal to F naught e raised to power iota omega t. Clear? So this is force oscillator. So please beta pay attention. Okay, this is very important. Second unit very important, and first topic is very important. All other topics are based on this topic, force oscillator. Now second is its behavior is of two types. One is a transient behavior and second is the steady state behavior. So behaviors of this oscillator are of two types. First is the transient behavior, and second behavior is called steady state behavior. So what is the difference between these two behaviors? First suppose we have a damped oscillator and it is oscillating. So it is oscillating with its natural frequency, that we have done in the previous chapters, that what is the natural frequency of a damped and undamped oscillator. We know that. And when we apply a force, now we apply external force to it. Now it is under the effect of that force, but it is going to oscillate with its own frequency. Yeah, but when it is going to oscillate with its own frequency and external force doesn't affect it and it is zero, then its behavior is transient behavior. Its behavior is transient behavior. But when its natural frequency dies and it is all under the effect of applied force, external force, then its behavior is steady state behavior. So we will do one by one each, because our next aim is, what is our next aim? To find the equation of motion. Second aim is to find the equation of motion, and after equation of motion, the solution of that equation. So first we will find out equation of motion. So write down next the equation of motion. Equation of motion for force mechanical oscillator. It is a mechanical. We will do electrical in the next lectures. First we will do force mechanical. So for equation of motion. Equation of motion. The construction is like same. Construction is like same. A mass is attached. Clear? A mass is attached to a string. Clear? With the now we are applying external force F naught. F is equal to F naught e raised to power iota omega t, and restoring force that acts in this direction. Clear? And same with the mass. With inertia and elasticity, it goes from mean to extreme position, then comes to mean position as we have done in the previous. But here only the difference is we are applying for continuous oscillations, for continuous excitation, we are applying a external force, because when damping is more, there is energy loss. So to compensate that energy loss, we are applying external force so that the oscillator continues oscillate. Clear? So now equation of motion. Now here is one extra force, that is F is equal to F naught e raised to power iota omega t. So one force is, that is a restoring force, that we know. Restoring force F1 is equal to minus Sx. And second is the damping force, because it is also a damping oscillator, damped oscillator, that is equal to, in the case of mechanical oscillator, that is equal to minus R. This is, and third, this is a resistance, and third F3, that is equal to F3, this is the damping constant, then F3 is equal to, yes, that is equal to F naught e raised to power iota omega t. So combine these three. When we combine these three, we get minus Sx minus R dx by dt plus F naught e raised to power iota omega t. This is the net force, and this is equal to according to Newton's second law, this is equal to mass into acceleration. It is equal to mass into acceleration. Mass into acceleration means double derivative of x with respect to t square. So we have the equation of motion is like this. Yes, negative side we have m double derivative of x with respect to t square plus Sx plus R dx by dt, that is equal to F naught e raised to power iota omega t. So this is our equation of motion. Clear? See? Now find, our aim is, this is equation of motion. Equation of motion for a force mechanical oscillator. Now our aim is to find out the solution of this equation. How we can find out the solution for this equation? Let's suppose the solution of this equation is x is equal to, that we have also supposed in the previous articles, x is equal to a e raised to power. Yes, suppose the solution is x is equal to a e raised to power iota omega t. This is the solution of this equation. If this is the solution of this equation, this solution must, where a is the any constant, then this solution must satisfy this equation. So we find out the first derivative of this, then second derivative of this, then we put the values. You can also put here a vector. Yeah? You can also put here vector. We don't know a is a vector or scalar quantity. Yeah? That we came to know at the end. Yes, x is equal to first derivative, that is equal to, yes, a e raised to power iota omega t and constant iota omega t comes here. Then double derivative, then again differentiate it with respect to t, that is equal to, yes, that is equal to a e raised to power iota omega t, iota omega, iota omega, iota omega square, iota omega square, iota omega square, iota square is -1, so this is equal to minus omega square a e raised to power iota omega t. So this is first derivative and this is second derivative. So put the values of first derivative, second derivative and the value of, you can also put your vector in this equation. So when you put the values, this implies, yes, m into second derivative. Second derivative is minus omega square a e raised to power iota omega t, yes, plus s x plus s into x. X is a e raised to power iota omega t. Clear? And plus r dx by dt. Dx by dt. So dx by dt is iota omega a e raised to power iota omega t, that is equal to f naught e raised to power iota omega t. So this is our equation, and you can write in the start that this is a steady state behavior. This is a steady state behavior. This is a steady state behavior. Transient behavior I will explain you at the end. I will tell you for transient, I will write here for transient behavior. For I have also tell you at the start that in transient behavior the oscillator does not under the effect of a force. So for transient behavior, f is equal to this f, that is equal to 0. So for transient behavior the equation is like this. So I will explain you at the end about this equation, r dx by dt, that is equal to 0. So this is for transient behavior. But when there is a force, oscillator is under the effect of force, then that behavior is steady state behavior. So we are doing here now steady state behavior. So this behavior we will do at the end. Yes. Now e raised to power iota omega t, I think it is common. So cancel out this e raised to power iota omega t. So what is remaining? What is remaining? That is equal to, yes, minus m, yes, minus m omega square a plus s a, yes, plus r iota omega a, that is equal to f naught. So this is we have here. So now a is common, write common a, minus m omega square plus s plus r iota omega, that is equal to f naught. So a is equal to f naught over minus m omega square plus r plus s plus r iota omega. Yeah. So this is a, but we want the solution. We want the solution. Now see here, a is not real quantity, it is a complex because here is iota. So now you can write here vector. Yeah. Now put the value of a because we want the solution. Solution is x is equal to, this is steady state behavior. So keep in the mind that this is a steady state behavior. I write this equation at here because we will explain it. I will explain it at the end. Equal to 0. Then I rub it. Now I rub it also. Yes. Now we have this, but we have x is equal to a e raised to power iota omega t. So put the value of a from here to here. Yes. So I write here vector x is equal to a f naught upon minus m omega square plus s plus r iota omega e raised to power iota omega t. So this is our x. This is our x. Yes. Now this is which type of behavior? This is very important, beta. Please pay attention, a very important topic, and the value of x is used in every article, every upcoming articles. This value will be used. Yes, x is equal to this. Now, yes, I take something common. What I can take common? I take omega common from this. If I take omega common from this, what this is r alpha minus m omega plus s over omega. So this will be, now multiply and divide it by you can say minus iota. Multiply and divide it by minus iota. So multiply and divide it by minus iota. So we have minus iota f naught e raised to power iota omega t divided by omega. Yes, minus iota, when it goes outside minus iota, iota is here. When iota is multiplied by iota, it is minus 1. Okay, and minus is already here. So minus minus plus. So we have only r. Now iota, because here is no iota, here is no iota, but sign is minus. So this become positive and this become negative. So we have plus iota m omega minus s over omega. So this is x. Here minus iota. When minus iota multiplied by iota, iota here is minus 1. Minus minus is plus. So here is only r plus, because this is minus, this becomes plus. This is minus, this is plus, this become minus, and iota outside. Yeah. So this is our x. So keep in the mind that this value is used in every article, next article. Yes. Now write it equation number first. Write it equation number first. Iota omega t. Write it equation number first. Okay. Now what is this? I write here r plus iota m omega. Beta, this question also comes in short answer type. That what is this? This says Zm, that is called mechanical impedance. And this part, you know, r depends upon damping, real part, and this part m omega minus s over omega. This is due to, you can say, r is damping constant, and this is due to friction or viscosity. This is due to damping force, and damping is due to friction, or it may be due to viscosity in the case of liquids. Yeah? And this is m omega minus s over omega. This is called yes, m omega minus s over omega. This is called reactance. And m omega, m is in the case of inertia and s is in the case of elasticity. So m omega is due to, this is inertial reactance. This is physical importance of this. Sometimes question come, what is the physical importance of this impedance? So m omega, this is inertial impedance because m is mass due to inertia, and s due to elasticity. So s over omega, this is you can say elastic reactance. So combination of these two gives total reactance. So this is the physical significance of this impedance. Clear? So next question comes. Next is that if I put this r is equal to, because this is a real part of impedance and this is a imaginary part of impedance, because I write r plus iota m omega minus s over omega, that is equal to Zm. Okay? If this arrow is in inside means center, you can say, then it is a complex quantity because here is iota. Here this is real part. So I can write R is equal to Zm cos phi, real part, and m omega minus s over omega, that is equal to Zm sin phi. That is equal to Zm sin phi. So if we put here Zm cos phi plus iota Zm sin phi, can I write Zm is common? This is cos phi plus iota sin phi, and this is equal to Zm e raised to power, because cos phi plus iota sin phi is e raised to power iota phi. So this is equal to Zm. So instead of Zm, you can write Zm e raised to power iota phi. Clearly, if you want to represent it graphically, you can write here, if this is Zm and this angle is phi, inside this, on x-axis horizontal part cos of phi, on y-axis this part is Zm sin phi, and this Zm is equal to r square plus m omega minus s over omega square. Zm, magnitude of Zm is, magnitude of Zm you can square, and adding these two, Zm is equal to r square plus m omega minus s over omega square under root, squaring and adding. Okay? And if you want to find out the value of phi, you can also find out phi by dividing these two equations. When you divide this equation by this, Zm cancelled, so tan phi is equal to m omega. This is also important and used in next articles. This is tan phi. So this is beta, magnitude of Zm. This is angle tan phi, and this is our x. This is our x. This is also complex. You can write here x. Clear? Now this is Zm. R plus iota m omega minus s over omega is equal to Zm, and Zm is equal to Zm e raised to power iota phi. So can I wrap it? I wrap it this. Now, yes, if I write here, this is equal to minus iota f naught e raised to power iota omega t divided by omega into Zm vector, because this is Zm. Clear? And put the value of Zm, that is equal to Zm e raised to power iota phi. So x is equal to minus iota f naught e raised to power iota omega t divided by omega into Zm vector, and Zm vector is Zm e raised to power iota phi. Clear G? And can I write it as e raised to power iota omega t that is minus phi. So this is our final value of x. This is our final value of x. Clear G? So this is final value of x. Now you can also put f is equal to, you can also put, because f is equal to f naught e raised to power, this f is equal to f naught e raised to power iota omega t. So instead of f naught e raised to iota omega t, you can put f naught cos of omega t plus iota sine of omega t. We can put this. So this is equal to f naught cos of omega t plus iota f naught sine of omega t. Here. So here you can also put this. So when you put the value of this, you will find the real part of force is this, imaginary part of force is this. Similarly, you can find out the real part of displacement, because x is in the mechanical oscillator. What is x? X is a displacement. So please beta, pay attention on what is our Zm is also here. This Zm. Okay, pay attention. Now, yes, if I put you a question that what is the phase difference between this x is a displacement and force, Then what is force means? F naught e raised to power iota omega t, because F is this. This is the magnitude of S. ठीक है, तो force the part the e raised to power iota omega t is in the force part. Only phi is with this. If we from this you will find out what is the phase difference between x and f. Yes, the phase difference, if we have any vector A, I rotate it by iota. Iota means a phase of adding angle of 90 degree. Angle of 90 degree. So here is minus iota, here is minus phi. So the phase difference between x and f, that is minus pi by 2 plus phi. Minus pi by 2 plus phi. Minus iota means minus pi by 2 and minus phi is this. Now question arises, which physical quantity is leading and which is lagging? So x is equal to this. So x lags behind the, or you can say x lags behind the force by an angle of pi by 2 plus phi. So you can also say x lags behind force by pi by 2 plus phi. Then no need to write minus because lagging. Or you can say force leads the displacement by an angle of pi by 2 plus phi. Force is leading, displacement is lagging. You can see. So this is about the phase difference. Now if I say what is the real part of this displacement? Yes, real part. To find out the real part, I write it as minus iota f naught over omega zm. Put e raised to iota, you can write it as cos of omega t minus phi plus iota sine of omega t minus phi. And here when you multiply it, open the bracket, cos part is with minus and you have minus iota f naught over omega zm cos of omega t minus phi. Iota with iota is minus plus, so plus f naught over omega zm sine of omega t minus phi. So from this you can see that which is the real part. Real part is this. So real part of, you can write here, if force, real part of force is F is equal to F naught e raised to cos of omega t, and real part of displacement is F naught. This we use in every article, sine of omega t minus phi. So you can use any from this, real or imaginary. So only we take magnitude, F naught over omega zm sine omega t minus phi, the real part of x. Okay, this is real part. Okay. Now this is about the real part. Then our next is, what is the maximum value of amplitude? You can, maximum value is this. So amplitude is f naught over omega zm. Amplitude is f naught over omega zm. So maximum value you can say, maximum value, or you can say amplitude f naught over omega zm. This is the maximum value. Okay, we know that na, x is equal to a cos of omega t minus phi. So जो cos या sin दे नाल हुंदा ताडे कोल, ठीक है, that is the amplitude. So here is f naught over omega zm. So this is about the displacement. Now if you want to find out the velocity from this, you can also find out the velocity from this. How can you? So that we will do in the next lecture. Clear? So please be careful when you are doing this. Thank you.